Hey everyone, welcome back. Episode 9, starting a brand new design series. And I'm really looking forward to this one as this is going to be tapping into something that I just recently got into. So it's going to be a lot of fun. If you guys have seen the link and you see the title is Designing Fantasy Crypto Mining Rig, first of all, let me explain. Fantasy as in something that I would like to see, uh, that takes care of a lot of the issues that, as far as cooling, uh, dirty air, um, potential issues with living near a salt water source, like along the coastline. Uh, Sometimes you get salt air corrosion, where the salt in the air, when you have windows open and open circulation, where it actually will corrode the metal. I worked at a couple of companies, and one of the big issues that I've heard and seen was these big metal buildings, even though they were coated with a weatherproof and non-corrosive, and they were actually made from non-corrosive, like galvanized metal with a really nice paint coat on them, they would still corrode. And that's when I first heard about salt air corrosion. So it is a real thing, and it's definitely something that you want to protect against at all cost, especially when you're running thousands of dollars worth of electronics. You definitely want to protect that as much as possible. So throughout this process, this design process, and it'll probably be a pretty long one, I'm guessing just as many episodes. I'm going to try to use a lot of different techniques, preformed metal, uh, maybe even some uh, sheet metal bending, uh, depending on how the design goes. I've got something in my head. I haven't done a lot of sit down and write, because usually I just see it in my head and I go for it. Probably even some plastic pieces, so you might be able to see some plastic mold design, because that's a very tricky, lot of brain work on that one. So without any more waiting and blabbing about it, let's get right into it. So what I'm going to do is I'm going to go ahead and create a new part just for now. That way I can do a save, create a new folder in my designs, and we're going to call that, we'll just call it not fat, fantasy rig. Something that I would like to see. And, this is something that I could probably do some varying prototypes with just stuff laying around the house, some ideas that have initially come to mind, uh, like an old shop vac, as far as a housing. Um, but we'll get into that. Um, So let me go ahead and let me do. Let's see. How am I going to do this here? We'll start on the. I guess we need to start on the framework. So my goal is to make it a self-contained unit that can house up to 6 GPUs, which is a graphics processing unit, and have all basically everything is inside one unit. So we'll see how that goes. So let's go. You know what? Let's just play with the body design, because I've got something in my head, and I think I'm going to do it as a revolved entity here. So, and maybe this could be a maybe this can be a single unit that slides over the whole assembly. And then from there I can try and gauge the sizing. You know, that's something that I do need to know. Let's pull up whoops, sizes, common motherboard sizes. Because I know they've got, yeah, ATX, micro ATX, and so I wanted a plan for the, which I'm assuming is the largest, the ATX. Let's see, we got computer form factor. Oh god, there's a lot of. We'll go with ATX. I think that's like the most common. All right, that's power supplies. That's not what I want. The motherboard. Motherboard. Standard ATX. Okay. Wow, I've never seen a Pico ITX before. That's crazy. Alright, so ATX motherboard. Originated in Intel. So 305 by 244 in millimeters. So I can actually. It does have a whoops. 12 by 9.6. So let's start off with that. 12 by 9.6. So if our base has a 15-inch diameter, that will definitely provide enough room for one of those to be on the bottom. And what I'm going to have to do is actually see if I can find some models of PCBs, or, well, motherboards. PCBs, printed circuit board, in case you guys wanted to know. Whoops, that's not what I want. So, we'll set up a guideline, another one. Actually, we'll go ahead and do a, give me some bearings here, and then I want vertical, infinite length. Just set him out here somewhere, and then I'm going to go ahead and dimension that. Since we're going to shoot for a 15-inch diameter, and I want this to maintain my midpoint, so that'll be 7.5 inches. Relocate that. And so most of the cases that I've seen have an opening in the bottom, and I'm not quite sure why that is. I'm guessing it's for air exchange to the outside, so it doesn't just. But then again, when you're in a case, it doesn't have that same thing. But it is, and then they have the standoffs. So, alright, we'll play with it. Let's just see what we get here. And let's see. Six GPU. Now I seen somebody have a really cool looking, strange design on a, looked like a hexagon type design. So I may have to dig back through and see what that looks like. See if I can find some dimensions on that. And I don't want to spend too much time looking, so I'm not going to worry about it. We'll get there. So 15 inches, and I don't want it to be a cylinder, so I don't want it to look like that. You know what? Let's go. You know what? I actually need to do this. We're going to start a new part and call this one body base. That'll give me a guideline. Top plane, sketch. Do a circle. And we'll dimension that. That's going to be 15 inches in diameter. Yes. And I think I want this. Right now, I'm not going to worry about the material just yet. Because I think I want this to be like preformed metal. Like in a press. Like they do kitchen sinks. I don't know if you guys ever get a chance, you can watch a video on that on YouTube. They're pretty cool how you got this big machine and it just presses these metal plates into these preformed sinks. So that'd be kind of the same principle here. It'd be more like a dog bowl, honestly. Alright, so let's do... Let's do a 1.5-inch extrusion on that. And we should be able to shell that. In a while. Shell. And let's see. I need to make up a let's see. I believe 14 gauge will work. .14 gauge sheet metal is 5/64. Yeah, that'll be fine. Let's show the preview, and I want this should be the exclusion face, I think. No, no, that's not right. Delete. Yeah, we want that face to be removed. See what that looks like. Now, I definitely want a radius in there just to make it look nice. So, let's put... let's do a 1/2-inch radius on the outside. Honestly, I should have done that first. Let me back up a step and do that. Actually, I should be able to do this. Then put the 1/2-inch radius in there. Yeah. Let's see what that looks like. Then we'll shell it. There we go. Alright. The foundation is laid. So my interior dimension, I did not pay attention to what I had the setting for. Okay, so that's my interior dimension. Excuse me. myself on mute there. And then I'll have to get the dimensions for the varying motherboards that can fit in there between the ATX, Mini, and Micro. I think that's what I want to design for. Yeah, I'll have to think about that. I'm pretty sure that's how I want to do it. I'll definitely have to consider airflow, and I have some ideas about how to create a closed system to keep this thing down to just above freezing using some micro refrigerant technology that I discovered. And I actually have a set, a full complete set that I'm going to do a test build and see how it works with one of my rigs that I'm planning on doing. So that's going to be a lot of fun. I hope. All right, so let's see. We got that. Copy that. And we'll save that for now. So this is going to end up being this by half. That way it slides inside, or I could have it slide to the outside. Up to, actually I think that'd be better. So I want to slip fit. So I'll do 7.5. Let's see, a slip fit at least 1/10 of an inch. So it'd be half of 1/10 of an inch all the way around. So let's go 7.6. Yeah, I'll do it that way. All right, now let's get a funky ass design here. So, and then we'll shell it as well to that intersection, and then we'll come up. Also need to get some dimensions for some GPUs. Let's see what this looks like. Let's do that 3 inches. We'll do 12.5 degrees on, whoop. Oh, 12.5 degrees on that. And let's get a dimension for that. Let's go 8.5. Give this one 65. And what kind of a let's do 40 degrees on that. And then I'm going to smooth all this out and make it a transitioning type deal. So we'll go ahead and do 60 degrees on that. Give that a height. Do 13 inches on that. Lucky number 13, right? All right, let's add some contours in here. Let's go with a big number at first to see what that looks like. I may end up doing different ones on these. Oh, there's not enough. Okay. So that's good there, and then we'll do, see if we can fit that one in. Yeah. That actually go through? Yeah, it did. Okay. Alright, so now we're going to revolve this feature. Seriously. Oh, I got to get out of that. Okay. That's the axis of rotation. Oh, we'll call this the beehive. How about that? Now this will change, obviously. This just gives me an idea of kind of to play with it a little bit. Let's see here. I can do that. So far that's not, I don't know, man. That looks kind of funky. We'll keep rolling with it, and then I'll change it later. Alright, so we're going to shell this. Maybe. There it is. And that's going to be the same thickness as the other one, so 5/64. Yeah, I'm already not liking that just yet, but oh, I know what I want. Right in the center of that thing. Yeah, we're going to have a hole there. And that'll be for airflow. Let's do 1.5 inches. Oh. Okay. 3 inches. Yeah. Extrude cut. Oh, whoops. Whoops. Nope. Want it to go. Oh, come on. Give it to me. I don't like doing it that way. Through all. Alright. Save that feature for now. Ooh. I just had an idea. Yep. I know what I'm going to do with that. Alright. So now we're going to have... let's see. I need to look at this again. So I need perpendicular to that plane. Perpendicular to that plane, I need holes all the way around. So I should be able to... Nope, that's not what I wanted. Let's see. That's a revolved feature, so that's going to be... So I want... Let's see. Actually, I want to come back down this way. Alright, we'll look at that in a minute. Can I put a plane on here? Yes, I can. Tangent. Second reference. Is that? Can I do it with just that? Okay. Second. Oh, I think top is what I. No. Okay. Okay, stop. Why? That's not what I want. Can I do that? Nope. Yeah, been a while. Forgive me, folks. Been a while since I did these complex geometric designs. Second reference. I guess I don't. Pick one until it works, I guess. Nope, nothing works. Oh. Okay, it likes that. Oh, yep, okay, there we go. That's what I want. Okay, that actually makes sense. Alright, so I should be able to do sketch on that plane. Now I'm wondering if I want it there or not. Let me hide this real quick. Honestly, I do need that to be on. I'll go 1 inch for now. And go up to next so that it only cuts that thin part out. And then I want that feature. A revolved cut. No. Do a circular pattern along that. And I want 6 of them, which they'll be 60 degrees apart. Yeah, this is going to be crazy. I don't know if this is going to... Alright, so each of those so far, I'm not sure if I like this or not. We'll see how it goes. Alright. Let me go ahead and turn my lines back on so I can get an idea of what's going on here. So, intake, and then so I want that to be the intake. These will be the intakes for the GPU. Let's do this. Let's create an ATX board real quick. And let's verify that size 12 by 9.6. And I believe these will probably be close to 0.093 in thickness. There's two typical thicknesses for printed circuit boards. I mean, there can be thicker depending on how many layers. But I'm going to guess that a motherboard is going to be on the 0.093. The other is 0.065, and that's probably 9275, but 0.093 is as good as anything. And let's do. I want to color that green just because that's what I used to do all the time. Makes it easy for me to remember that it's a printed circuit board, and in this case it'll be a ATX motherboard outline. So we'll save that as ATX motherboard outline, and that's fine. Alright, so we're going to create a new. Wait, where are all my. That was weird. My toolbar disappeared on me here. I don't know why it does that. That's not what I wanted. Oh well. We're going to make assembly from part. And for right now, I think this is going to be like the shell assembly, I guess. We'll insert the, oh, nope, body. Oh, I need to turn that off. Hide that in there, so I don't need to see that in there. Alright. Make that concentric, and then we're going to put this to here. That, yep. And then I'll lock the rotation on it as well. There we go. And we'll save that as the shell assembly. Now, if I can cram everything that I want to cram in here, that'll be kind of freaking awesome. Alright, then we're going to make an assembly out of this for it to be the whole assembly. This way I can control. We'll make that transparent for now. And let's put in the outline for the ATX. I'm going to assume at least for now, I'm just going to assume that I'm going to keep that at least 1/8 of an inch off. I'll have to look and see what the standard is on the standoffs, and then I'll modify that. That's not a hard thing to do. From here we go. We'll do right plane to right plane. And front plane to front plane. Okay, so how is that not big enough? It's weird. Did I put in some numbers wrong or something? 12.9. That should... Okay, let's see what we did here. So that should have... Or 9.6 by 12. Yeah, that was the... Well, let me verify what my body base is. It's 15 inches in diameter. Alright, we'll make it 18. And we'll modify the body to match. So we'll do 18. Half is 9, so 9.1. That makes that a little bit funky there. Ain't any worse than... It still works. So, does that work better? Alright, we're in there. Now it would be nice if I can... That's the thing. That's going to be hard to design for as far as the CPU placement goes, because I don't think they're 100% the same on every single one. So I'm going to have, because the CPU fans, from how I understand it, it pulls the air down through the heat sink. So basically it's just flowing. Because when I put my hand over it, I don't feel any pressure, but I feel a slight vacuum. I wonder, let me make sure, because that's always puzzled me. It doesn't seem like that's a very good way to do it. Airflow direction. Okay, so they blow hot air away from the CPU. So it's supposed to pull air, cooling air from around and up through, and then blow it out. Alright, we'll go with that assumption for now until proven otherwise. Okay, actually that gives me an idea. Yeah, okay. I don't know that this is going to be tall enough, though. I might have to make it a little bit taller. Okay, so if my exhaust is getting pulled away, then I can direct it through and have it escape and then recirculate back to the cooling unit I plan on putting in here for this. It almost looks like a diesel tire, doesn't it? Or wheel. Let's go ahead and hide that because I don't need to see that right now. Alright, so far, this is not bad. power supply units are going to be a bear to fit in there, because those are pretty big. And I really wanted to make this like an all-in-one unit. So basically it'll have to be multi-layered and bigger, taller, I think. Let's see. Let's try the average. Full-size graph card long as an 8, so about 1080x, 10.5 inches long. Less powerful cards will be significantly smaller. So let's do this. Let's go with the 10.5 inch. We'll bump up. We'll give it. Yeah, I'm gonna need some extra room. So we're gonna go with 12 inches. Let's see here. Okay, yeah, this is gonna have to be much taller because right now I'm 13 overall height. All right. So I'm gonna be a ½ inch off the ground already for this when it connects to the base. And then I need, got at least 4 inches for the power supply units, at least, plus another, I'm gonna say another at least 3 inches for the tallest component on. No, because those fans are pretty big too, especially if you get a big old honkin' cooling fan. So I'm gonna give, let's do 6 inches for that. I can always change that later. So we're 6 inches and 4 inches, 10 plus another 12. Alright. I'm gonna go with 24 inches for now. Why didn't it? Yeah, it's gonna have to be regenerated. Yeah, that freaked it out. Haha, I'm gonna have to fix that. Yeah, 24 inches. Alright, so we're gonna go 6 here. And then we'll add another 4 to that, so if we add another, okay, so that's 12. And this is going to be our 18-inch mark, I think. Why is it doing this? That needs to get pulled back. What is it doing? Where's all my dimensions? Alright, let's undo all that. Let's take it one step at a time. Trying to do too much at once. Alright. Six here. That pushes that above that. Yeah, we're getting there. That's a very tiny line. 12.5, 35. Let's make this. Make that 10 degrees. And we'll make that 25 degrees. We'll make that 30 degrees. Now I should be able to bump this up a little more here. Let's do 24. That puts me outside, so if I bump this up to 18, this up to 12 maybe? This up to 6. Okay, we're back in. I really don't like the way that's turning out. That's too... doesn't give me enough room. Let's try this. Nope, that's not gonna work. Let's get 18. Then let's see what that looks like. That's a little more. That's different. We'll go with that for now. But I think I might need to move those holes up, especially. No, they're intake. That should work. Yeah, this is weird so far, eh? Not so much what I had in my head, but that's kind of what happens. Kind of takes a life of its own. That looks like more to scale. Alright, how much distance do I have between here and here? The world wants to know. That is not at all what I asked for. Let's try again. See if this gives me what I want. No. Be helpful if I could have a have to find out the dimension for the 1080. Let's see, what's the dimensions for a, what is that, 3060? Is that the nice, or the nice? The latest graphic cards out? .36 by 140. So, what's a 1080? It's pretty big. .267 by 112 by 40 millimeters. What was the other one again? That one's even bigger. That's the link by 60. Let's see. What's the latest Ryzen, or not Ryzen, but AMD? I forget. The 6000. Is that right? Oh, they got the 6900 now. Oh, no, I wanted dimensions. .267 by 120 by 50. Man, that one's still bigger. Okay, so that's the size we're going with. Hopefully that's the biggest. If not, then obviously. Alright, let's do a new sketch, and we'll just make that real quick. Just make it a block. Let's see, I want a... Yeah, we'll do a front plane. And we'll do a square. Well, rectangle, honestly. Alright, we're going to do 36 millimeters by 40 millimeters. And then we'll extrude it. We'll do a mid-plane extrusion. That'll make it easy to align. 61 millimeters. And let's just, we'll chamfer all the edges. Yeah, that's fine. Oop, that's kind of big. Yeah, I don't care. You know what? That's going to take too long. And let's see, we'll call this, we'll have this be the, let's see, we have the fan side. So let's actually do this. Let's we'll just make a couple of extruded circles here real quick. That way we kind of get an idea where our fans, no, that's not where I want. I want this center line, horizontal, midpoint line. That way I can do this. that. Then we'll do an extruded cut. Nope, that's not what I meant. Nope, 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 nope. There we go. And we'll go down just a ½ inch. Mm. And then I think what we'll do is we'll make the, let's see. If I look at one of those, an AMD 33090, they have fan. They actually have one fan, and then this is blocked off, but this is fine. And then they have the attachment, so this is where the exhaust is going to be. That way I'll just keep track of that. Let's do a centerline vertical. How do I want to do that? Yeah, we'll just do it that way. That way I know that that's my exhaust. Good enough. I know it looks nothing like it, but it's just for reference. Large GPU mockup. And we'll make this black. Yeah, I can't do it too dark or else it's really hard to see the other features on it. Alright, good enough. I like color coding things so I remember what they are, and it helps sometimes with looking at stuff. Okay, so this will be the hanger. Yeah, this will be the hanger side. So I'll have to get that information, because those are pretty standard too, honestly. That's going to be the crypto rig. Let's do this. Okay, if I got that, let's just bring one in and see what it looks like for now. Oh, Jesus, are you kidding me? Oh, God, I thought it was, okay, I thought I was looking at the thin end. I was like, wait a minute, that don't look right. So it's gonna hang, the hangers are on, always on the exhaust side, so it's probably gonna hang something like that. Let's do... I'm going to make this parallel with that, but I don't want... Okay, that's pushing out. Let's see. What's the distance here? I need at least from here to here. So, okay, we're going to just put it right there for now. And then I think what I'm going to do is that origin? And this item. I'm going to do a circular array with it. Maybe if I can find the damn thing. Oops, hello. Circular, yes. Equal spacing, I want 6. Direction, I want it there, right? Yep, that's what I want. Okay, see, this gives me a good idea. So it lets me know that I'm going to have to change the geometry of this thing. Exhaust is here, so that's fine. That's how I want it. And I think what I'm going to do then... God, those are so huge. You guys kind of see what I'm going with this. So I'm going to actually need to make it a little bit wider. Because right now it's crashing into each other. What was my first one? That's my first one. So let's look at that. Pull that out. Let's see how far I need to pull it out so it looks decent. Just a little bit. Exhaust is going out the top, which is what we want. So it looks like I need a little bit more. Oh, I'm covering up the... Okay. So I'll just have to offset those. Alright. So let's do this. Let's go ahead and lock the bottom height down to be... What? That's not what... I don't understand why I did that. What line am I looking at here? Okay. There we go. I'm calling that... And then my interior, let's see. Where is this one? That one's there, so that's going to be perpendicular to that plane. So if I do this to this, and we'll set a dimension. So I got let's do 2.875 inches. 875, thank you very much. so far I'm actually kind of digging this. I don't know if anybody else is, but if it looks good, let me know. I mean, obviously it doesn't because it doesn't work because I don't have it tweaked right. But this, I mean, this is all part of design. Form follows function. And in this case, I like to defy that because one of the jobs I had before, they always had me cramming as much stuff in these little tiny packages. Like here's an 87 Subaru. Can you put it inside of this jar of peanut butter? No, I can't. But I can put it in the side of a trash can. So, alright, I'm not worried about this design just yet, because I want to see if I can't get some of the other pieces in there. So, let's look at... Let's look at some pretty heavy-duty power supply units. Let's see what those are. That's great. Oh, yeah, I did see these guys before. There's a 2000 watt one. Holy sheboygan. What's the size of that mother? Uh, 2500 watt. Well, since there's a 1600 watt for 6 GPU. That is, I think they're reselling those. 1600 watt PSU dimensions. Here we go. Alright, let me pop. This just gives us an idea. Because if I ever just actually put something like this out to market, I would actually include a 6 GPU motherboard, a power supply, and stuff like that, and then all they would have to do is put in the GPUs. Plus all the other things that I'm going to be putting in there. Yeah. Alright, so we're going to make another box. And do that from the top plane is fine. Nope. Whoa. So I'm guessing it's probably 3.3875. That's right, we'll do the 3.39. That's the thickness. So we'll do, and I'm looking at, what plane did I do this on? Top plane. Okay, so we'll do this side as the 7.87. This side is the 5.91. And then we'll extrude it to 3.39. Probably doesn't include the switch. I'm sure there's going to be some that are, but if I mean, that's pretty good if I design it for that. There's a fan. Oh, I need a picture of it. Let's see where the fan is. We got one side. Oh, this is actually kind of a nice. Let's show you guys what I'm looking at. So, chamfer on those sides. And let's see. power supply is there. Then the fan is on top. So on here, fan is on top. And that's funky looking. Oh, I should just see if they can send me this. That's kind of cool. Alright, we'll do the same thing that we did on the other one. We'll just put the fan on the top. And I'm guessing that the airflow... that's kind of interesting. I'm assuming airflow goes... I would think it would go from outside to inside and then it blows back out, but that may not be the case. I'll have to double check that. So, let's see. So exhaust is going to be the same side as the power cable. That makes sense. Alright. Fan is on top. And this will be our top. What the hell? Ask for the dimension. 4.5 sounds good for now. We'll extrude that down to a bench again. Oops, I'm going to chamfer these sides like they are in the... just to give it a little bit of flair. There we go. And then I need to see where is the front. So I'm going to call this the back. So what I'm going to do is the same thing I did before. Create a sketch on that plane. I'm just going to offset that in. Why not? That looks good. And then I'll extrude that and quarter of an inch. There. That way I know that that's exhaust and this is intake. Gives me an idea. Alright, so we'll just do 1600 watt PSU mockup. Okay. And we'll make this a different color too. Why not? Let's do that. Kind of uses. Alright. Now we get to bring this in and see where we can squeeze it. Insert components. Where is it? There we go. That's pretty big. Alright. So if I do this, let's make this parallel to that for now. Because you got to have your risers go into your So honestly, it would make more sense to have, because you're going to have a bunch of wires coming through there. So honestly, it would make sense to have, let me break up that mate real quick. So exhaust here. So that means the side opposite, it has all your cables coming through. So if we did something, what the hell? That's not what I wanted to do. Let's see here. Yeah, we could have the power supply hanging out on the outside. Let's do this. We'll do parallel. And then we'll go top plane. We'll go parallel there. Now I got straight up and down. So if we do something like this, let's change transparency of that too so I can see what it's doing there. So if I bring this out, so all I would actually have to do, not even that, let's see here. Go straight up. Okay, I don't like that because then I would have to put this on a stand. Which legs would actually be a pretty good idea since we need the clearance for the height. Oh, that actually might work out better that way. Alright, let's play with that. Actually, yeah, I like where I'm going with this here. Alright, let's do a quick save on this. And I'm going to do a quick break, kind of gather some of my thoughts, and then come back to this. So, we'll be right back here in a few minutes. Alright, and we're back. Alright, continuing off this, honestly, I'm kind of excited about this because you could actually use smaller power supplies if need be, and do two, one on each side. So, I mean, there's the accommodation for that. It looks like, though, I will need to bump the height up a little bit more. But we're working. Alright, so I've got the exhaust there, which is where the plug-in will go, and I'm going to need stands. So, let's see. How do I want to do that? I think what I might do is modify the base. Yeah, let's do that. Let's modify the base. I think I have an idea here. Let's do... Okay, let's bump the height of this base up. Let's bump that up to 5 inches. And then what I'm going to do, let's see here, I want to... This really doesn't matter. And I think I'll have an intermediate. If I do that, alright, let's just keep playing with it, because I think I know what I want here. We're going to do front plane. Oh, whoops. Do a sketch on the front plane. And we're going to do vents. What? Let's do center line, vertical, infinite length here. Put it right there. And then we'll go... let's go 1/4 of an inch from the bottom. Did I fat finger that? Yes, I did. Let's try that again. Okay, and then we'll do... Let's see, that I need it to slip fit over. So I'm going to make that go down 3/4 of an inch. Whoops. 3/4 of an inch. And then I will have the top set down on top of that a 1/2 inch. And then that'll give me the same 1/4 inch gap. So let's do that, and then this, how does that look? Alright, I'm okay with that. Let's extrude cut that. We'll do through all both. And then we're going to take that feature and do a revolved cut. Or no, an array. Circular pattern, circular array. And we need, hello. Equal spacing. Only for 180 degrees. then we'll go around the origin. Or it doesn't want that. Okay, let's try. Show that. Should be able to. Alright, I gotta create an axis here first. Features, axis, cylindrical. Is that what I want? Yes, that's what I want. Alright. This is just some guideline. Yep, that's what I want. Okay. So, move that above here. There we go. Boom, boom. Now I can circular pattern that bad boy. And equal spacing over 180 degrees. And let's do, I do 30 of them. That works. That'll be my, basically my inlet to my bland HEPA filter, which I'll have to find a round HEPA filter. Alright, let's see what that does. Yes, we're going to have to modify this. The mates. Hello, where are you, mates? Nope, wrong one. I need the body. Oh, for Pete's sake. No. Shell assembly, that's what I need. Okay. Mates. That's fine, so I need to break that. Delete that one. And that should slide right up. Oh, I need this face and that face to have 0.5, but I need it to flip. There we go. So far, so good. Okay, there we go. Now, now this is going to come up. Shit. This will be here, roughly. And this, we have the ATX outline. I get the mates here. I want edit that feature. No, that's not the right one. That's the one. Okay, so let's delete this one. And I want that to be no. I'm gonna do that. There, that's actually okay. Ooh, I forgot about something. I'll have to come back to that because I'm going to have to modify this design. Because this will need to house a HEPA filter and a dehumidifier with an exchange so that you can empty the humidifier or dehumidifier, because you take the moisture out of the air, it collects in a basin, and then you have to dump it every so often. So that's how dehumidifiers work. It takes the moisture out of the air. So that's going to be an interesting ordeal. I would need to find basically, I wonder if there is such a thing as a dehumidifier with HEPA filter. Holy God, those are huge. Wonder what the volume. I would have to. Let's see. Hundred milliliter air, air purifying function. True HEPA. Activated carbon. I would need a very small one. Yeah, like micro size. But I mean, this is kind of the same concept here. How big is this one? That's way too complex. Oh, that by itself is still 15, oh, a little over 14 inches tall. Ooh. Small. 150 square feet. God dang, $400 though? Jesus. Oh, that's exactly what I'm looking for. Holy shit. So, I would need to see how that works. Oh, that's so loud. My apologies. Okay, I just want to... Where's the dehumidifier part of it? There's the... Wait, was that an actual dehumidifier? But it's just a... Oh, it's just an air purifier, but it's not a dehumidifier. But this is on the right path. Let's see, what's the size of this bad boy? Seven cubic feet per minute. Oh, it has 3 separate speeds. And vehicle interior, that's pretty big. Included with mount. Let me see what this one looks like, because that's really tiny. Oh, that's beautiful. That's exactly what I'm looking for. But I would still need to install a dehumidifier though. This is pretty badass. I think I'm gonna add to cart, but no, it's not that. And then, oh wait, let's see, let's look at the cart, and then I can move that to save for later. That way, I can see that. Okay, let's look at that again, and I want to see the size on it. "20 times per hour." That's actually really good as far as circulation goes. Because I guarantee you the thing that I'm designing is not going to be bigger than a car. So you could actually have it on a very low power mode. So what these will do, these HEPA filters, they will pull salt out of the air. Oh, here we go. So it's almost 12 inches in diameter and little over 4 inches tall. So actually, let's go ahead and model that. Oh my goodness, I got so much stuff going on here. Let's go ahead and create a new part. What did that say now? 11.77 inches. And we have extrude 4.05 inches, I think is what it said. Yeah, 4.05. And then it had some crazy cool high capacity. Really nice. Okay. I wish I could get better. Let me see. Here we go. It's a pretty decent. Okay. That must be the mount. There's your blower, motor. So, that filter, okay, I see. So it sucks it in through those filter and it blows it out these other fans. So we have intake all the way around. We have intake and exhaust. Alright. At least that's what it looks like to me. Oh, come on now. So let's make this look funky. Let's try that. That's a little bit much. Oh, it's yeah, that's probably gonna be closer. Yeah, still a little. There we go. I like that. That looks pretty close. And then, let's go ahead and put the whatchamacallits in there. Oh, no, I want... Oh, first I need to create an access. Let me do that first. Oh, maybe. Is that? Yeah, I'll have to do that first. Okay. Nope. Nope. Features. Access. Boink. Done. Bring that up just to see it better. Yeah. Okay. Now, right plane. And we're going to do... Basically, I'm doing the same thing I did on what I made. So, do an eighth inch, and I'm just guessing here. I'm just making it look somewhat similar to the product I just saw. Yeah, that's fine. And then we'll extrude that all the way through all both. And then we'll take this and hello, that and that. And we'll do a circular pattern. Holy smokes. 180 degrees. Eh, close enough. There we go. Close enough, yeah. I think it looks good. Alright, and I'm actually going to save this as that part number. This is and it has a black with that trim. What is this called again? Atom car air filter. That's what I'll call. Well, we'll just do this. Ah. Come on. Alright, maybe not. Come on. Let's... Okay. What am I... Oh. Did I freeze up? Okay, good. Thought I froze up. Haha. That. That will actually leave that color. And then I'll color all those black. Well. Why not? Looks like a hockey puck of sorts. Okay, I'm gonna... No, I'm not. Not yet. Alright. So, I'm going to bring that in. Actually, was it? I was trying to... Oh well. So that is pretty good. Man, that was a good find. So we'll do this. And the inside of that. Centric. And until I know more, well. What? That's not what I asked for. There we go. Gotta make sure we pick the right thing. Put that in there. Air purifier, baby. That's what I'm screaming. So let's look for a small. Travel size dehumidifier. That's going to be way too big. Well, let's see what that says. Top rated best choice, 1,200 cubic feet. Too big. 1,100 cubic feet. I need very tiny. Hmm. Okay, this is not working. What's this? 10,000 BDU. What the fuck? 16 by 12 by 30. They obviously don't know what tiny means. I need really small. I may just have to make my own. Micro dehumidifier. Let's see what that comes up with. What is this? How does that work? Just hang and go. Works area is 333 cubic feet. What's the size? 9 by 8.5 by 2.88 inches. But it looks like, what are those in there? How does it work? Spill and mess free, hang and go. Super dry. Last 20-30 days for recharging the silica. Oh, that's not bad. 6 ounces. So you get the. Oh wait, I think I looked at this before. Eva Dry wireless mini heat dehumidifier. What's this one? It's a little bit more. I think I've seen this one before. I like the idea of that it has capsules that you just every, what did it say, 30 to 60 days, I think. 500, more than enough. Easy to use and recharge. Requires no batteries or cords. So it'll actually let you know that it's to capacity. No leaks or spills. Non-toxic crystallized silica gel technology. This is pretty slick. Alright, we're going to do this. We're going to add this one to cart. Go to the cart and then put that in the safe for later so we know what it is. And I guess I'm going to try and model this real quick and see where I can fit it. Was the other one better? As far as the size goes? Because this one looks a little smaller. 9 by 8.25 by 2 5/8. 2 7/8. This one is, oh, much smaller. I like this better. Okay, this one's smaller. Okay. 5.5 by 5.5 by 2 inches. Nah, that's bullshit. There's no way. That's an oval. Or that's an ellipse. That's not a circle. Yeah, there's no way that's the right size. Let's see if I can find some better dimensions on this. It's a Home Depot for 20 bucks. Why am I not putting it on my Home Depot? I don't understand. I'm silly. Well, shit. So this is every 10 to 12 hours. I guess it depends on how much moisture's in the air anyway. So if you have to change it every 12 to 14 hours, then that's not going to be great. Your best bet would be to have basically a room dehumidifier, and then make sure you don't have anything outside of that going into your deal, because that'd be like twice a day. Now wait a minute. Unit absorbs before needing to recharge the silicone gel beads. So what is this talking about? Oh, maybe the batteries? What? Wait, what was I reading? Now I can't find it. Alright, whatever. So, there's no way that's 5.5 by 5.5 because that's not a circle. I think they're lying. Let's see what. Why does my thing keep disappearing? It's so weird. Huh? Oh, wait. Let's try. Okay. Let's try. What do I want? I want a slot. Hello? Yes. Thank you. And this again. It's going to be really close together. So that means shrink that down a little bit so I can, if anybody decides to talk to me today. Let's see. So we have, actually this would be great for our bathroom, honestly. Would definitely help. Okay, so change it out once every 30 days ain't as bad as 14 to 16 hours that I was thinking. I don't know why now I can't find where I read that, but alright, we got can I do, let's see, let's first put that there, and we want this, what, hello, this needs to be, can there's a way you could change that, I need to get this first. So they're saying I'm gonna go with 3 inches here, and then let's do, really, a circle with a diameter of, wow, why is it, technology, y'all. Let's go down here. Oh, that's radius. I need that to be a diameter. So 5.5, and that needs to be 1.5. Okay. And honestly, so that's not quite right. Well, that's got to be 5. Let's do 2.25. That kind of makes sense. Can I do this? No, that don't make sense. Honestly, I need it. Alright, so let's do this. Let's make some construction lines. Infinite length. Actually, we'll just put one here and one there. And since that's already centered, so we're going to do, oops. Aha, okay, that makes sense now. Kinda. So if I do from here and go up and over and back down, so I should be able to do a line. I went and tangent. Can I get a This is the only part that I don't like, is it's hard to do lines that are tangent to each two different sets of circles. In AutoCAD it was real easy to do that. Alright, so let's do, I want to extend the length of this, so I won't, oh my god. Okay, then we're going to go tangent to that one. Of course. That's not going to work. I'm going to have to decide where to cut it. Let's do some more construction lines. Let's do 40, hello, 45 degrees, infinite length, like this, there, and then we'll do, okay, that's not at all what I said to do, but okay. Whatever. Bear with me, people. Okay, that's fine. And then infinite length, and we'll go angle that, and then we'll do 45. So now what I need, it's basically a line tangent to here to there. To make this look decent. Honestly though, wait a minute, maybe I can get away with, because that damn near looks pretty close. It's just flat on there. You know what? Screw it. I know what it is that I'm looking at. We're just going to go, yes, yes. We're going to change that to construction geometry. We're going to go with that form factor. not quite right, but I'll know what it is. What was the thickness of that bad boy again? 2.5 inches. Okay. So we'll do an extrusion 2.5, and actually I do it mid-plane so that it's, yeah. And then we'll fillet all that 1 inch. That's a little bit over the top. I don't care. It looks decent. And this is going to be white. Of course, there's not really a white, but come on. I don't think I can get any. Can I? Yeah, that's what it gives us for white. I mean, unless I start doing like white plastic material. So, alright, that's good enough. That gives me some basic pill dimensions. Eva Dry E500. Eva Dry E500. Dehumidifier. So, and I want that to be after it's been filtered. So we're going to have to make room for that as well. Okay, that's not what I was looking for. Alright, let's bring that bad boy in. That's pretty small too. So what I'll have to do, this is going to be pulling in and cleaning air and sending it out. So some of these will be collection. I'll have to figure that out. Alright, let's look at this here. Put that right about there. And then we'll spin that bad boy and bring this straight in here. Now, if I design this right, I can utilize the components and actually, because it has a battery, so we'll have to have some smarts in there so it keeps that thing recharged. Or keeps it working. So I definitely need to be taller. And you know what I think I'm going to do here? Oh, that's a little bit encroaching there, so let's go ahead and move that out a little bit. And I think what I'm going to do is just duplicate that and put one over here just to show that it's possible to have, instead of one big power supply, you can run two small power supplies and still fit it in here. Alright, so I need to make that taller and extend this part of it so that it makes sense. Well, I don't, let's see. Because I want an exhaust fan to pull all the heat out through the top for an open system. Now, if I'm going to do a coolant closed system, which I'll probably do another variation of that, because this is assuming like you're going to put it in somewhere where you're going to have, like in a basement, where the room's going to be, chill. And then I think I want another variation of that where it actually has that micro refrigerant technology I'm excited to play with. Alright, so far we're actually doing pretty good. This design is going a lot faster. I mean, I know it's far from over, but the initial mock-up is actually pretty damn fun. Alright, let's see. This one, yes. So if I bring, hello, how is it fully defined? Wait, what? Okay. Oh, yeah, that's not right. So that is going to have to go up to at least here. So once I push that up, let's see, is there a way to do that without? No, there isn't really. Not even if I do different angle on those. Alright, so we're just going to leave. We're going to go taller. I mean, considering that the new thing is the wire racks, and those things you can 6 feet tall. So right now I think I'm 2 feet, but I'm only doing like 18 inches in diameter. Is that what I did? So in most 6 GPU rigs are like, what is it, 3 foot wide by 18 inches in diameter or some shit. And they use a lot of cooling fans, which this, if I'm pulling through with a high energy exhaust, then I'm well ahead of the game. And that's something else I'll have to check out, is what I can get for that. Because that'll have to be an attached deal too. Okay, so that's coincident with that right there. So from, oh, so from here to here is what? 2.5 inches. So if I go up another 3 inches, I'm good. Okay. So if I go up another 3 inches, let's see what that does to this. Okay, that's not bad. And if I bring this up another 3 inches, what does that do for me? It still gives me some. Looking less and less like some crazy cool structure. Let's go 19 here. Let's go 20. 22. Oh, too much. Yeah, too much. 21. I could change the fillet of those. Let's see, where am I at here? If I make this, if I make that 2 inches, and I make these 5, that doesn't really change much for me. Let's just see what that looks like. And these will go away on the free flow. So I think, yeah, I'm gonna put those to sleep for now. Still not enough. So really this is more going to look like a damn cylinder. Because I don't think I can turn these 90 degrees and get them all the way around in there. Maybe at an angle? Could I do it that way? That would be weird. Let's see what that looks like. Let's delete that. Actually, we'll just delete all these. That'll be interesting. So, if my exhaust, I still want the exhaust that way. And if I do it right, I can push the air up through to the outside, maybe? Let's see, what does this do? If I do this, and I make this parallel to, I won't be able to grab that, I don't think. No, that's, okay. Where is my... Let's turn that on for a second. Alright, so if I do this to this as parallel, and then I need it to be straight up and down. So let's go to top plane, and is that how I want to do it? Yes, okay, yeah. And then I need that to be a distance away. So let's see, how far away can I be? It's at 1 inch now. Let's do a half inch. Nope, that puts it in 3/4 of an inch. Okay, that's decent, I guess. And then what? Where else do I need to? Oh, okay, I need to lock it in. Hooks up through there. Let's look at this here. So honestly, I can come down. Let's see, can I do... Come on. Just give me that point. There we go. No, I don't want it to be connected. Oh, I know. Duh. Is that gonna work? No, it's not. Can I get a dimension of that and see what it does? Nope, because it's given me the 0, so it's not going to read that correctly. Let's see. Can I select the midpoint of this line here? I cannot. Let's go into that body. So let's bring that in. And I'll add a point. Maybe. There we go. To the center of that. And hopefully that'll do what I want. Give me a reference point to tie into. Because that should be... yes. So we will try 2¼ inches and leave it at that. Okay, so, oh, wait. That's not going to work. Because we have the plugs coming out of here. And that's definitely not going to be enough room. So, let's see here. Let's try this. See where we're at. Oh, no. That coming out? Yeah, it is. So, I can give that a different angle. Modify that just a bit. And have it come all the way up to here. So, let's give this one... seriously? 15. What if can I do this? No, why is that going so weird? Let's see what that looks like. Okay, so I can actually push that up a little bit more. Now this will be subject to change because I have to account for internal support features. Oh, if that's... okay, then the riser will come off at this side. Yeah, that's how it should work. Okay, so that's locked in place, right? Okay, I was going to bring that up just a little bit more. And we're still not crashing into... now that's going to be hard to do because of the hanger. So I'm going to have a hanger or a cross support going this way. Let's see what this does. Too close. Shit. It's not going to work. I mean, I kind of like it, but what if I did it the other way? Okay, let's try something different. I kind of like where I'm going with this, but it's not quite there yet. Let's try this. Let's see. I need this way. Oh, but we're gonna... okay. Side opposite will have the plug-in. It's a little crazy. Side opposite the riser connector. I'll need to make room for the 6 or 8 pin or double 8 pin connector that goes to those. Of course, I could put some connector holes through. It can go up and over. I mean, it's not really a completely enclosed system. I wonder if I could do... I'm gonna have to play with that. Once I get more components in there. So that'll be a fascinating thing to play with. Okay, let's try what I was thinking. But wait, what? That's not what I was... Oh, that's right. Boom, and then, come on, give me the... So because it's, yeah, it's in the middle of it. Okay. SolidWorks sometimes. Oh, whoops. So let's run that parallel. And let's get a distance of 0.25 maybe? No, that puts it... Oh, wait, no, that's all right. Yeah, because I got to get that aligned. That's aligned with that. There we go. And I'm going to need more gap there. I can actually go pretty far up there. We're not crashing into it. But it does have the... Yeah, that's definitely going to change. So this is definitely going to get bigger around. Yeah, this is going to be crazy cool. And difficult to design. Alright, I'm going to leave that like that for now, and we'll go ahead and break that around, and yeah, we're still crashing. So it really doesn't matter how I do it, I'm just going to have to make that top a little bit bigger in diameter. And then from there, I mean, I got most of the components in. I don't have the risers, so I'll have to get some dimensions on those and kind of make a model of them. I can actually do wiring in this. It's just a pain in the butt. But it's okay. We can do it. I do like how that's coming in. So we'll need a support. We'll need ventilation coming up through so it gets to this. And it recirculates that, or that it dehumidifies the air. And then actually this, all I need is a... That can be passive. That can be a passive vent. So I could actually make that a passive vent so that this is doing all the work. Pushing air through. That'll make it easier. And less power consuming. That's for sure. Alright. Well, I think... I don't know. It's kind of a crazy idea. Let me know what you think of in the comments. If you see this and you're like, what in the hell are you doing? Or, you know, maybe something supportive. I don't know. But that's a pretty good episode. Just 2.5 hours. And as always, if you feel like going over, checking out I have a patron set up. And the link is right in the title when you first go to my YouTube page. Anything helps, and there's pretty cool rewards for any level, even the smallest one. So if you feel inclined to support the channel and see it grow, and see me start making stuff like this, even in prototyping stages, that'd be awesome. Anyway, I appreciate everybody for stopping by, and until next time, I'll we'll get some more done and see how far we can get on the next episode. Thank you so much for watching. I appreciate each and every one of you. We'll see you later. Till next time, next week.